Hello students, let us review wave optics of class 12 physics. Earlier, light was thought as a corpuscles as per Newton. Initial first draft of light is made by Newton. He thought it is a corpuscular theorem. Elastic particles with rectilinear propagation. So with these corpuscles, he could explain reflection, refraction. Reflection by repulsion by the surface. He thought reflection due to attraction of refracting surface. Both alternately. Attraction and repulsion causes diffraction. That was the theory. The first theory about light. Various colors because due to sizes and masses of the corpuscles. So with this theory, many other phenomena could not be explained. Interference, diffraction, and other things could not be explained. Then Huygens wave theory has come. So there is a improvement over the original draft. It is always difficult to first give original draft. Based on original drafts, we can do many improvements. But draft itself is having a very importance, whether it is atom, whether it is light, whether any subject. It is a starting point. Okay, Huygens wave theory. Huygens thought light as a wave and travels in the form of wave fronts. You see, the source of light is there. This is a wave front from which all waves will, the same phase will form one say arc. Again here same phase will form one arc. Again each wave front acts as a secondary source with maximum intensity along the direction of propagation. Suppose this is a wave front. It can give light in this direction, in this direction, in this direction, back also. But the wave front in such a way that maximum intensity is towards radially outward. That is why wave propagates in outward direction. So each wave front can again a second wave front, again third wave front. So light travels as a series of wave fronts. That is why many phenomena could be explained with this. So every point light source, suppose this is a point source, then we have all round spherically these wave fronts move. So we have a spherical wave fronts. If it is a tube light, then we have a cylindrical wave front. If it is a tube light, we have a spherical. If it is a tube light, is cylindrical wave front. Like that, if you see if it is a tube light, we have cylindrical wave front. If it is a plane light, we have plane wave front. Like that, we have several different types of wave fronts. Huygens assumed light travels as a longitudinal way. Actually, it is traveling transverse way with crests and troughs. Longitudinal, only sound travels longitudinal way. But during the time of, at that time, when he is modifying, he thought light as a longitudinal way, and he knows that for a longitudinal way, the medium is required. So he thought vacuum is having some medium called ether. Some medium called ether in that. This is ether. So vacuum is having ether in it. So that is why the light is traveling through the space as a longitudinal way. But later it was proved wrong. But other things proved correct. The wave front moving as a second source. So he also is the first man to express that colors are due to a wavelength. Different wavelengths with jar. So different wavelengths have different colors. Additionally, he could explain interference, diffraction, polarization and total internal reflection with this theory. What he could not explain is the lack of medium in vacuum, the photoelectric effect. What is this photoelectric effect? When the light falls, electron emits. So as a wave, he could not explain how electron can emit when wave falls on it. If it is a particle, it can bombard and electron can come out. As of this theory. If it is a corpuscle, light as a ball, if it hits it and electron can flow. But as a wave, it cannot hit an electron. So he could not explain it. He could also, Compton effect is also he could not explain. So, but one thing, he thought velocity of light in a denser medium less than rarer medium, this could be explained by him. Okay? We'll go to next step. Because Newton thought velocity in rarer medium is more, velocity of light in rarer is more than that of in denser mediums, could not explain. He explained this one, but This is, you could explain the difference. Now further improvements have come. Maxwell's electromagnetic theory. He thought life is an electromagnetic wave. Life is an electromagnetic wave. You see that way with electrical systems. Whenever electrical system is there is a magnetic field associated with electrical vector. Whenever electrical vector is there is a magnetic field associated with a moving electrical field. If it is stationary electric field, no magnetic field. A moving electric field will have a magnetic field. So he proposed that velocity, it moves along with velocity of light. All electromagnetic waves move along with velocity of light. So the velocity is frequency into lambda, wavelength. And he has derived as, because both electrical and magnetic waves energies contribute for light propagation, so root of 1 by root of epsilon naught mu naught. This is nothing but E by B. E is 1 by 4 pi epsilon naught, mu is mu 0, like that. E by B will give the velocity of light. So it has come to 3 into 10 to the power 8 meters per second. He is first arrived, Maxwell's electromagnetic theory. Then on further improvements, then Planck's quantum theory has come. He explained light as energy packets. Is a small packets of small quanta. Energy is released as a wave, but also as a part of packets of quanta. He is not telling it as wave. He is again telling it as corpuscle. It is like a number of packets of energy source. 1,000 bullets, 10,000 bullets. Like that energy, the photons are coming as packets of quanta. Is called photon. So each energy is defined as h in u. H is the Planck's constant, and nu is the frequency. So as the frequency increases, the energy of the incident ray is increased. Frequency energy is directly proportional to frequency and indirectly proportional to lambda, because C is n lambda. Frequency C is fixed, so they are all opposite. So as frequency goes up, lambda comes down. So this is the energy equation for light, h lambda. So if you see the electromagnetic wave, if you go to small frequency to higher frequencies, the energy, X-rays, gamma rays have more energy because their frequency is very high. Lambda is very less. On the other hand, radio waves might have less energy. Okay, we'll go for that. So this could explain photoelectric emission, because as a packets of quanta, when it hits the electron gets this energy and emits out. So he could explain photoelectric effect with the energy of packets. Of course, this Einstein has used this theory to explain his photoelectric emission. Compton and Raman effects are also explained with this quanta energy concept as photons of packets of energy. But he could not explain diffraction interference, because these are again waveform. Diffraction interference is a waveform. So this is purely again a particle form. This is a waveform. This is a particle form. Again, Huygens has explained as a waveform. He has explained as a particle form. So it has changed from wave to particle, particle to wave. And later, de Broglie has come into picture. He explained that every body behaves both wave as well as particle. Everything, whether it is light, whether it is body, whether it is a person, whether it is a planet, everything is of both nature. Light behaves both as wave and particle. Not only light, everything. When passes through small openings, comparable to the wavelength. Wavelength is how much? 5,000 Armstrong. So if you compare that slot, small openings, then it behaves as a wave. Otherwise, if it goes with a higher size in the space, normal, then it behaves as a particle. So in fact, every moving thing is having a wave nature. It's lambda, we don't feel it because of the less velocity compared to that of light. So the velocity is compared to that of light, you can feel lambda. Suppose electron. Electron moves velocity is incomparable to that of light. You see, he is h nu. H nu is hc by lambda. What is h nu? Nu is here frequency nu. Yeah, I have written n, it is nu. So nu is c by lambda. So hc by lambda. This is equal to mc square. It is not half mc square. Please note down. This is not, the velocity is coming from 0 to c. No. This electron has come with velocity c. Electron has come with velocity v. They have not started from 0 to v. So half mc square, so mc into v, v is the electron velocity or any moving part velocity. Then cc gets cancelled out. Then we get what is the lambda here? Lambda is equal to h by mv. So any momentum, suppose if I am running at 100 kilometers per hour, so a car is going at 100 kilometers per hour, it is having a momentum. So, but still its lambda is very less, so we cannot feel it. So h by mv is the de Broglie's wavelength. Okay, so this is a normal wavefront. Well, let us see. See, we have seen that wavefront of Maxwell's theory, how he has explained reflection. Suppose this is a wavefront coming. The wavefront coming. AB is the wavefront. It is like this. The all the focus of all same phase. When it is hitting the plate, it is getting reflected. The first A got reflected, then after some time B got reflected. Again, the same wavefront travels in this form. But what is happening here? This is a denser medium, this is a lighter medium. Whenever there is a reflection, wave coming B is on this side, coming here, they have taken a 180-degree turn. So that we say there is a phase difference of pi. Reflection through a wave theory, whenever there is a reflection, there is a phase difference of pi or lambda by 2 is the path difference. So when this, by the time wave came here, this wave has come to this point and again they are moving. So but the between this and this, the path difference is lambda by 2 and phase difference is pi. Okay. Now is the refraction. This is the wavefront. Here the velocity is reduced in the medium, so it has taken a lower velocity path. By the time it has reached here, and again they are taken same velocity. So the AB front has converted into A double dash, B double dash, A triple dash. So wave, it is moving as wave either in the medium or outside or while reflection. So this is how Huygens has explained both the phenomena reflection and refraction through wave theory. Here intensity is proportional to A square. AM is amplitude. This light is having a crest and troughs. Crest and troughs is electromagnetic wave. The crest gives amplitude. Trough also giving amplitude minus amplitude. So A is proportional to amplitude A square, but amplitude is proportional to inversely proportional to the distance from the source. Suppose this is the point source, as goes up, amplitude comes down, the intensity goes down. And 1 by x for a point source and the proportion 1 by root x for a line source. Suppose this is a tube light. As goes, amplitude gets reduced as I go x, 1 by root x, in the ratio of 1 by root x. When amplitude is reduced 1 by root x, how the intensity is reducing? A square, so 1 by x. So as you go along the direction y, the intensity is reduced by 1 by y, proportionality. Again, if it is a point source, it is reduced by 1 by y square, a deep, more reduction. Okay, this is the intensity. Now let us see, there are two waves. This is y1, this is y2. So these two waves, when they interfere, now we are going to a chapter of interference. We are going to a chapter of interference, diffraction. So first let us understand how that when these two waves come and meet here, so this one wave is in this direction, another wave is in this direction. They combine to form a resultant wave. They form resultant wave. If this wave, how they get added? From here, if I shift it here, and this theta is here. So what is the total amplitude? Y1 plus Y2 cos theta. Y1 plus Y2 cos theta. Phi is in between, angle in between. So this is the I component of the combined wave. What is the Y component of the combined wave? Y2 sin phi. Y2 sin phi is the combined wave. So how this wave resultant is acting? This is the resultant. How it is acting? This is tan resultant angle is y component by I component. So yj by ij. So this is how the waves are interfered and producing a common wave. So due to this, either their amplitude gets increased. If this cos phi is minus side, amplitude gets decreased. So depending on their interference, the crests and troughs, the amplitude changes. Now we see there is another form of adding in a vectorial form. A1, A2 amplitude, A1 square plus A2 square plus 2A, A1, A2 cos theta. This is the intermediate, this is the cos phi, 2A1, A2 cos phi. So I is proportional to A square. So I can write as I as I1 plus I2, here is I as I1 plus I2 plus 2 root I1 I2 cos phi. So I is proportional to A square. This is given. This is a half mv square. V is omega a. In a wave theory, we have seen maximum velocity is omega a. A is amplitude, omega is angular frequency. So omega square a square is mass is rho into v. So if you see, if the omega is fixed and the wave is fixed there, so it is proportional to a square. The whole thing is to show that intensity is proportional to a square. So when I suppose both intensities are same, this intensity is same. The intensity same is amplitudes are same. Amplitudes are same. Then it becomes what? I plus I 2i. This 2 into root of I 2i. So 2i into 1 plus cos phi. It becomes 2i into 2 cos squared phi by 2. That is 4i cos squared phi by 2. If I1 and I2. Okay. This is the common intensity of the both waves. It is the phi is the phase difference between them. So for a destructive interference, cos phi will be minus 1 at that point. In that case, how it will become? I1 minus I2, root I1 minus I2 whole square, or A1 minus I2. A is A1 minus A2. So like that, depending on for a constructive interference, for a destructive interference. X is n lambda. If it is for a constructive difference, we should have n lambda. If for a constructive difference, the path difference should be n lambda. Then they will be continuously is a 2 pi, n is 2 pi, 2n pi lambda. This one, phi's difference. So they can continuously A1 plus A2. A1 plus A2, it will become maximum amplitude. For a destructive interference, cos phi is minus 1. So 2n plus 1 lambda by 2 if the path difference, if it is lambda by 2, 3 lambda by 2, 5 lambda by 2 between the two waves, then there is a destructive interference. Okay. Now let us see Doppler effect in light. Suppose this is a source of light, is observer. When the light is moving, source is moving towards, suppose sun is moving or some source is moving, so the number of wavefronts will be compressed. So the frequency is increased. So how the frequency is related? F0 into square root of c minus v by c plus v. V is the velocity of the source. C minus v by c plus v. So if we take it into simplified form, y minus v by c. So v by, if I v square by c square, if I remove it because it is negligible, because v is far less than velocity of light. So in that case, f becomes f0 into 1 minus v by c, and the change of frequency is v0 into minus v by c. Minus v by c. This is the frequency. So if it starts moving away, then what happens? The frequency reduces. If it's coming towards, frequency increases. If it's moving away, frequency reduces. So the light emitted will shift from blue to red. That is called red shift. The light emitted will shift to, because frequency is reducing. When frequency is reducing means lambda is increasing. So with j, it is going to red side. So it is red shift. If it is moving nearer, it will shift to blue side. Suppose with j, it is somewhere yellow. So if it is moving away, yellow, then it will shift to red. If it is moving towards us, it will shift to blue. So that is called red shift and blue shift, depending on the stars moving towards us or away from us. Their frequency varies. Okay. Now let us see one interference example. Continue. So this is an example. y1 is 12 sine omega t plus 30. This is the phase difference is 30. It started from 30. Omega is 10 t. Similarly, another wave y2 is 5 cos 10 t. You see both cases omega is same. So find the resultant of the superimpose. When they superimpose, what is the resultant? So 5 cos omega t can be written as 5 sine 10 t plus 90. It's a 90-degree phase difference with sine. I can write like this. So in that case, between these two, y1 and y2, what is the phase difference? Here it is plus 30, this is plus 90. So phase difference is 60 degree. So if I apply formula, a square is a1 square plus a2 square plus 2a1 a2 cos 5. I am getting a1 square is 12 12s are 144, 5 5s are 25. So cos 60, I am getting 15.1 square. So what is tan phi? Tan phi is y2 sine theta, 5 sine 60. y2 sine 60. Here you can see. This is the x-axis. This is y1 with 30 degrees phase difference. This is y2 with 60 degree phase difference with y1. Then I have superimposed here y2 here. Then I get what is this one? y2 sine 60. So by y2 sine 60 by y1 plus y2 cos 60. y2 sine 60 by y1 means a1. a1 plus a2 cos 60. So I am getting the resultant angle is 16 points, between this is 16.63. If I add the original phase also, then become 30 plus 16.63, around 46.63 is the phase difference. So y resultant is 15.1 is the amplitude sine omega t plus 46.63. So what happened here? The amplitude has increased. 12 plus 5 is supposed to be 17, but because of the phase difference, they are not with 0 phase difference. They are with 60 phase difference. It has become 15.1 in place of 17. And with this phase difference. Now this combined ray is moving like this. Suppose another problem, y is given a1 sine omega t plus kx1 plus theta 1. And y2, a2 sine omega t plus kx2 plus theta 2. Then what is the phase difference? So theta 2 minus theta 1 is the phase difference as we have done here. Plus not only this will also add to phase difference, kx2 minus kx1. This is a distance from the starting point. X is the distance from the starting point. kx2 minus kx1. Both together will give the phase difference, and we have to add the amplitudes accordingly. We see a constructive difference where both waves are constructively and amplitude is doubling. So 12 plus 5, 17 it will be. Here also 17, 17, 17 like that. This is the amplitude. This is the combined wave is moving. Suppose this is a destructive. Destructive means 12 minus 5. It will become 7. So the amplitude will become 7. Here it is equal. So amplitude is becoming 0 this drawing. But otherwise if these two go to a destructive interference, then I will get only 7 as my amplitude, crust and thrust. They are destructive. And intermediately between 7 to 17 they can interfere with phase. So these are the interference of two waves. Now let us understand YDSA, Young's double slit experiment. There is a double slit here. The gap is D. We need a single monochromatic source. Suppose if I put one bulb here, one bulb here, they are two different sources and they are not monochromatic. So from the same source I am taking two rays. So they become monochromatic. When these two rays are falling on the screen at a distance of D, so we have observed it is producing dark and bright fringes. Dark and bright fringes, FRINGES. See, central, we will get bright fringe, then dark, then bright, then dark. This is the first dark, second dark, third dark, fourth dark. As far as bright is concerned, central bright, first bright, second bright, third bright. So it is central bright is defined as separately, because both sides we are getting first bright, second bright, third bright. So let us observe what is happening here. So two rays, one ray from here, let us say at this point is a P. At this point, both rays, what is the path difference between these two? Phase difference or path difference between these two. If this is D, if I draw a perpendicular to this, so this length and this length are equal. And both lengths are equal, what is the path difference at this point between these two rays? This portion. This portion is, if it is D, they are given it as D. So if it is D, and this is theta, this is D sine theta. So what is the path difference is? D sine theta. So path difference becomes D sine theta. But if you see the symmetry, this theta and this theta are same. So the same phase, if I rotate, I will get this theta, same theta. From the center to the point P, both are same. So it is so small, maybe this is around 1 meter, this is around 0.1 mm or 0.1 mm maximum D. So this theta is so small, so tan theta can be written as sine theta. So sine theta is this y divided by D. So d sine theta is equal to y divided by d. D sine theta is equal to tan theta, that is equal to d y divided by d is the path difference. So delta x is equal to path difference d sine theta is y by d. So when I am keeping y as subject, y is equal to x d by d. xd. What is happening this y? Y is a magnified path difference. See, path difference is x d sine theta. But as we increase this distance, I am only magnifying this. Delta x may be in terms of some Armstrongs, maybe 5,000, 3,000 Armstrong, 2,000 Armstrong, very small value. So by arrangement of such a 1 meter here, 1 mm or 0.5 mm here, so I am enlarging by d. Suppose is 1 meter, this is a 0.5 mm, so 1000 mm, so around 2000 times it is multiplying my delta x path difference. When I am multiplying 2000, at least I am getting in some mm. So I can, in my screen, the difference is only mm or centimeter. So that is the reason this arrangement is to multiply, this is a multiplying factor, magnifying the delta x. So d by d is a magnification factor for the delta x. So that is the y. Otherwise, how much you will get y? Suppose if it is nearby, how much you will get? Very small. I cannot distinguish between first bright and second bright. So I need a microscope to distinguish them. So to magnify, I have provided d by d. So what is the y? Delta x d by d. So but at point C, what is the difference? It is coming, ray is coming from here, ray is coming from here, almost equal distance. They are at equal, it's a bisector, So equal distance. So here the path difference is 0. 0 means what? There is a constructive interference. Means there is a constructive interference. So we got a bright fringe. Both sources amplitude gets added up, it becomes 2a. So I got a bright fringe at the center. As we go up, if both difference is lambda, first is, let us see here, constructive. This is a dark fringe and bright fringe. So first bright fringe comes if their interference, their gap is lambda. The gap is lambda. If the gap is 0, we are getting central bright fringe. If the gap is lambda, that means 2 pi radians. Again we get frontal fringe. So if the gap is lambda, that means x is lambda. X is lambda. Then y becomes lambda d by d. So y becoming lambda d by d. So then we get first bright fringe. Both sides we get. Because from center this is lambda path difference. From here also this is lambda path difference. So both I am getting 5. Then 2 lambda, 3 lambda. Like that I am getting bright fringes. First plus lambda means 2 lambda path difference. 3 lambda path difference. Like the delta x is n lambda, I am getting nth bright fringe. Okay. Now, so what is the y distance? N into y d by d. Lambda d by d is the nth bright fringe. So from here, If I want nth bright fringe, fourth bright fringe, 4 into lambda d by d. So d by d is the arrangement. Lambda is the light I have used, whether I used yellow light, whether I used orange light, whether I used red light, lambda changes. So n is the number of the fringe width. Now let us see dark fringe. When we get dark fringe? When there is a destructive interference. When the path difference is either lambda by 2, because whatever a here, lambda by 2, it gets cancelled here, minus a. So they get cancelled. So we get a destructive interference. You see here, this is a destructive interference. When a here, I am having minus a of the other beam. When a here, I am having minus a. They are with a pi by 2 or lambda by 2, pi or lambda by 2 is their phase difference. So delta x is lambda by 2. So I will get first dark when it is lambda by 2 from here. So what is y distance becoming? Lambda by 2 into d by d. So lambda d by 2d. Subsequently I am getting again lambda. I have to add lambda. So this is dark is lambda by 2. Then again from here to here 1 lambda I have to add. So 1 lambda plus lambda by 2, 3 by 2 lambda. First one plus lambda, second one plus lambda. The gap between dark or bright is lambda only. Lambda is wavelength. Okay. So if I 1 plus lambda d by 2 becomes 1.5, 3 by 2. If I generalize, what I am getting? N plus half lambda. Delta x is n lambda. I am taking n as 0. 0 to this. So when I put 0 is here central point. 0 means if I am putting half lambda. Is half lambda. So suppose if I take n as 1, n as 1, 2, 3 and keeping central bright frame separately. Central bright frame is there. Other things I am denoting 1, 1, 2, 2, 3, 3, 1, 1, 1. In that case the formula varies. Formula becomes 2n minus 1 into lambda d by 2. Here if I put n1, what is becoming? 2 minus 1, 1, lambda d by 2d. Lambda d by 2d is the first dark fringe. Second dark fringe. Third dark fringe. If I put n1, 2, 3. So n1, 2, 3 represents number of dark fringe. Similarly, here also n lambda d by d. If n1 means what? Lambda d by d. So n1 means this is 1. Lambda d by d, first bright. So here conveniently central bright is treated as separately. So that is why we don't use n0 to this. 0 to 1 to 3 we don't use. We keep central bright fringe separate. And we use general formula as 2n minus 1 lambda d by 2d and n lambda d by d for the bright fringe. Suppose I want 10th bright fringe. From here 10th bright fringe. So simply I can put 10 here. 10 lambda d by d. Here I want to put say 10th dark fringe. So 20 minus 10th dark fringe. 2n minus 1 by 2d. So I have to give that much is the y distance. So what is this width? This bright fringe is having some width. So this width is called fringe width. This width is called fringe width. Fringe width is lambda d by d. This is lambda d by d. Central bright fringe having lambda d by d. Suppose, please note d by d is only magnifying as we have discussed. Suppose a slab of mu is introduced in one of the paths. Then what is the distance traveled additionally due to the slab? It is mu minus 1 into t. Mu minus 1 into t is the additional distance traveled by the top path. So by the time they come to central thing, here the path difference is mu minus 1 into t. So unless that path if I make, the central fringe will shift to the top side. So how much it is shifting? It is delta x. Mu minus 1 into t is delta x is equal to d sine theta is equal to y d by d. So if I am comparing, what is y becomes? Mu minus 1 into t into d by d. So central fringe shifts by mu minus 1 t into d by d. Then further lambdas will come into picture. Lambda and half lambda will come into picture. So the first central one will shift because I have introduced a glass slab here with a mu. So the distance traveled by this ray is more by mu minus 1 into t, thickness of the slab. Okay. So how much is central distance is shifted? Mu minus 1 into t is the delta x. So when I compare delta x with d sine theta, because this is the path difference, because both are meeting here. Then what is the path difference is delta x? The delta x is nothing but d sine theta. Sine theta is y by d. So delta x is equal to mu minus 1 into t is equal to d sine theta. So the y becoming mu minus 1. So in that case, central fringe will not come at 0. It will come at slightly up. Why? Because here it is traveling more. So to cover more distance, this has to travel more distance. So fringe shifts upwards. This we have already discussed. So let us see some examples on how the thing. Suppose a screen is there with a screen width 3.5 lambda on each side. How many maximas can be seen? We have central maxima, then we have lambda, 2 lambda, 3 lambda, 4 lambda. 4 lambda cannot be seen because screen is only limited to 3.5 lambda. So total we can see 7 maximas only on the screen. So if screen length is given, so we can say how many maximas can be find out from the screen is we can use this. Here you have seen. First is lambda, second is second lambda, third lambda, like that the bright fringes appears. Now let us say there is a screen of circular screen and monochromatic sources with 12 lambda gap are kept at the center. On this side and this side is a 12 lambda. So how many bright and dark images can be seen on the screen? That is the question. Two sources with 12 lambda gap, how many maximas and minimas on the circular screen can be seen? So now let us understand. What is here difference? 0. So when it is here 0, we have a central maxima here. Similarly, I have a central maxima here. Okay. Now, what is the difference here between two sources? Difference is 12 lambda. So 12 lambda is even multiple of lambda. So I am getting a bright here. I am also getting a bright here. So if you see in the first one quarter, 0 to 12, I will have a place where 1 lambda, 2 lambda, 3 lambda, 5 lambda, 6 lambda, like that all integer lambdas I will be getting where I will have a constructive interference. So each quarter I am getting 12 bright fringes and 12 dark fringes. So total 4 quarters will become 48, 12 and dark fringes. Okay. Now let us see. Suppose two sources are here. There is a path difference already existing at two openings. Then central maxima is how much it is shifting. Suppose the path difference is x. So I am drawing this line. Here it is x. Again, what is this? D sine theta. This is d sine theta. Because sine theta is y by d. So x is equal to d sine theta. X is equal to y by d. Then it becomes y shift is x into d by d. So at the source itself, if there is a path difference of x, it becomes x d by d. In earlier case, what is happening? In this slab case, it is also same thing. There is a path difference in the source itself. Of course, not before the source. Now we have after the source. Mu minus 1 into t. Mu minus 1 into t is the path difference when I have introduced. So this is the path difference. Automatically y shifts by that day. Y shift is mu minus 1 into t into d by d. So when the source there is a shift or there is a slab, it is all one and the same. Now let us say interference in other system. Suppose a light ray is going like this. It has bounced back. So the original ray bounced back and there is another ray coming. Both interfere here. Both interfere here. The light ray which is bouncing back and light ray which is going, both will interfere. So the question is, what is the minimum distance for them to make an interference point. So we'll say that we know once a light ray is deflected from a denser medium, we will have a path difference of pi. There is a path difference of phi after reflection, and it has, suppose it is meeting at A from there. So it has to travel A, come back to A. This is 2A plus pi. This is the total difference. So 2A plus pi is equal to, if the difference is lambda, then I have a constructive interference. So 2A plus pi, 2A, pi means lambda by 2. Pi means what? If the phase difference is pi, means distance is lambda by 2. So when I'm equating it lambda, so my A is coming to lambda by 4. So minimum distance required is lambda by 4 for them to interfere. Similarly, we have seen in the sound case also. Sound reflecting from a hill or a mountain, we need a certain minimum distance. But in that case, this path difference is not there. There is no path difference. It will come as it is. Sound is a longitudinal wave, it will come as it is. So here, but light wave, we have a path difference of pi whenever there is a reflection from a denser medium. Now let us see, understand other reflection. Here, first one, this is a slab of mu. One light ray is coming like this, getting reflected, and there is an interference from just above the surface. On the surface, one light ray is coming, one light ray got reflected. So what should be the thickness of this? If this is a mu, so how much distance it has traveled? Mu t plus pi, that is reflected. So total additional distance traveled is 2 mu t plus lambda by 2. Pi means lambda by 2. If this distance is equal to lambda, then I have an interference on the top of the film. So what is that thickness should be? Lambda by 4 mu. Lambda by 4 mu. If that is the thickness of the oil film, I can see in the colors here, right? Different colors, bright colors, constructive interference. Suppose the light ray is falling like this. Then it will take a refraction, then reflected, then it is going out. So another light ray is coming like this. It will have two interference. One is at this point, where this light ray is meeting the reflected light ray. Another is after getting reflection, this light ray after getting reflection also meeting here. So there is another point, it is meeting here. So these 2 points also it can have an interference depending on there are number of rays are coming. So some rays will get both rays interference. How the condition is coming, let us see. When there are 2 reflections are there, so condition for maxima is 2t is n lambda by 2, as both rays are getting reflected. Here both pi gets cancelled out. So in this case, that is again is talking of straight. So 2t, the pi here also getting reflection. Suppose one more getting reflection. So both are getting reflected. So the pi is cancels out. Then we get 2t is n lambda 2. Okay, this is how we are getting. Both rays are getting lambda by 2 getting reflected. So when interfering laterally, as I said, 2 and 3. So what is the path it is moved? Mu t by cos beta. So mu t by cos beta. This division here. Okay. So this is mu t by cos beta. This is again mu t by cos beta. Total length traveled is 2 mu t by cos beta, and when 2 mu t by cos beta is equal to n lambda, by the time it comes here, it with the gap is n lambda, then we have a constructive interference. Because here I am not adding pi, because this also got reflected, this also got one reflection. The pi get cancelled. N lambda for constructive interference, or 2n minus 1 by 2 lambda for destructive interference. Suppose if pi is not cancelling out, it is directly coming and meeting here. So then I have to keep pi also. I have to add mu by t cos beta plus pi is equal to n lambda. Pi means lambda by 2. So you understood all the 4 cases. One is only one reflection and meeting. Second is both are reflecting and vertically meeting. So it is going up, there is a ray going vertically up and meeting. So this is the interference. Third is, it is having a inclined path, more path in the medium, 2 mu by t cos theta and pi by 2. Pi also is adding, lambda by 2 is a path difference. Then both are meeting here. One ray will not, without getting reflection, and one ray after getting reflection. So accordingly, the pi is to be added, the length of the path difference to be added. Okay, now let us understand one more problem. Suppose it is given interference is seen at 3 lambda at this point, and after the second interference is seen at this point. This is first lambda, then we have 3 lambda at this point. This is a y1, y2, y3. So y1 is given, y3 is given. Distance. So what is this distance? He is asking. D between these two, what is this? So let us see. Let us say here thickness is T dash. Thickness is T dash. What is happening? The ray is coming and going back and having interference here. So 2T dash into mu. This is the distance traveled by ray. I am taking both got reflected. Both the pi is getting cancelled out here. 2T dash mu is equal to 3 lambda. Because the oil film thickness is going on increasing. Is 3 lambda. At this point, 2Tu mu, 2T mu is equal to lambda. Here the path difference is lambda. He has given path difference lambda, path difference 3 lambda, and he is assuming both got reflected and meeting because pi is not there. So when I do this one, what is T1? T dash? T dash is L3 tan theta. T is L1 tan theta. So when I minus L3 minus L1 is equal to D is the distance, it will become, when I substitute this 3 lambda minus lambda 2 lambda, it is lambda by mu theta. Mu lambda by mu. L3 minus L1. So I am getting this distance of D. Okay. I will go further. Suppose if sixth dark fringe of certain wavelength coincides with 10th bright fringe of other wavelength, find their wavelengths ratio. So we know 6th dark fringe means 2n minus 1 by 2 into lambda d by d, 2n minus 1 by 2 into lambda d by d, and the 10th means 10 lambda d by d, 10 lambda d by d. So when we equate lambda 1 is to lambda 2, 20 is to 11. So these type of problems we may get in interference. Now let us understand Lloyd's mirror with YDSC experiment. We need for a YDSC means Young's double slit experiment. I need two monochromatic sources. Suppose 2 slits, one slit. I need one monochromatic source. Here with one slit itself, with one opening itself, I am getting 2 light sources. How? One light source is going like this. Because a small opening, it can go like this also. One light source. Other light source, there is a mirror here. This is mirror. So a light coming from here takes a reflection and meets. And a light coming from here takes other end of the reflection and meets. So we observe at this point to this point, there are 2 sources interfering. 2 different light paths, different path lengths are interfering here. So again, the fringe pattern forms. What is the path difference here? We have to add geometrical length, we have to add, plus we have to add pi by 2. Pi is the phase difference, lambda by 2 we have to add with the reflection. Direct one, there is no reflection. So accordingly, we can get the. Now let us see a problem on intensity. I we know 4i cos squared 5 by 2. We have seen here. I is 4i cos squared 5 by 2. We got I1 plus I2 plus 2 root I1 I2 cos phi. So when I1 is I2, then becomes 2i into 1 plus cos phi. What is 1 plus cos phi? 2 cos squared by 2 minus 1 cos phi can be written as. So it becomes 4i cos squared 5 by 2. So here, so I is 4i cos squared 5 by 2. It is given at some point I is 3i. Find the phase difference. Okay, at some point I is 3. So if I put 3i, so what I am getting, cos squared 5 by 2 is 3 by 4. So cos 5 by 2 is plus or minus root 3 by 2. That means pi is equal to either pi by 3 or 5 pi by 3. 5 by 3 or 5, this is the phase difference. So we can write x difference. How we can write? 2 by lambda into x, or 2 by this is also phase difference can be converted to a x difference. Phase and what, how they are related? Suppose 2 pi phase is lambda. Similarly, 2 pi phase is one full circle. Similarly, lambda is one full circle. So lambda is 2 pi. So 2 pi by lambda into x is we are getting in terms of distance. So if I put x, we have to find out x. So lambda by 6, when I equate 5 by 3 is 2 pi x by lambda, lambda by 6 and 5 lambda by 6. So what is y1 here? Lambda d by d. So lambda by 6 d by d. So 1000 lambda by 6, and the other one is 5000 lambda by 6. So at these points, the y from the YDSC, I am getting an intensity of 3i. Where I am getting 4i? I am getting 4i at the wherever there is a full lambda path difference is there, n lambda. Total constructive interference I am getting 4i, because where 5 becomes, this becomes 0 or 2 pi. So I am getting full 4i. Now the same two sources is brought by Fresnel's biprism source. But he has taken up, this is a biprism. It is attached back to back, the biprism. One source of light, if I am sending here, due to its diffraction, the light can vary from this point to go to this point. So it is as if the source is here, one source. Similarly, the other side, by refraction, it is going up to from this point to this point. So as if some source is here. So with one source, by arrangement of Fresnel's biprism, I am having two sources, and they form a interference pattern here, bright and dark fringes. So now here I want D. This is D. In YDSC experiment we are getting, this is D between two sources. Okay. Here also I have to find out what is the source is 1, but because of the path difference, I have to add geometrically. In the same way here, how this D can be found out? We know, we have seen prism or lens shifting method. If I keep here lens, I get a bright image. If I shift this lens to this point with for a distance D, I am getting another bright image. So root of I1, I2 is equal to imaged height. Root of I1, I2, image 1, image 2 heights is equal to I. We have seen in our earlier lessons. So this is how the Fresnel biprism. So for causing interference, people have done different experiments. Now let us study about diffraction. What is diffraction? Bending of light rays around the corners is called diffraction. Suppose this opening is around lambda, very small. So light rays will not just go geometrically like this. They occupy some more place like this, as if light ray is bending. This bending occurs whenever there is edges, corners, and the gap is less, more bending. So it behaves as a wave. It is a wave front. When the wave front it forms here, automatically it gives in all directions the light travels. This is a diffraction. Let us study the diffraction. How it is? There are light rays are coming from sun. This is Fraunhofer diffraction. Fraunhofer diffraction means sun's diffraction, and Fresnel diffraction means a nearby source diffraction. Let us first see Fraunhofer diffraction. The source is coming straight. So if this is the slit width A, at the center we get a maxima because they do constructive interference. I am getting center maximum intensity. This is center. You see? center. Suppose if there is a gap is lambda, the path difference is lambda. At this point, path difference is lambda. So this is the path difference lambda. That means at this point it is lambda by 2 path difference. That means here for every light from here, we have a light of lambda by 2 path difference here. So this lambda, this half portion a by 2, whatever rays are going, other a by 2 c to b will go with a in terms of lambda by 2. So they destructively interfere and we get a dark fringe. This is the dark fringe. At what distance we get? Lambda by a and lambda by a on both sides. Because this is here. So this is lambda by 2. The path difference is lambda. So I am getting at a distance of lambda by a, I am getting a destructive interference. Lambda by a on both sides. Suppose if the difference is instead of lambda, I am having odd lambda, 1.5 lambda. It is 1.5 lambda. Then what happens? This is lambda by 2, this is another lambda by lambda, this is 1.5 lambda. So whatever rays are going in this zone are destructively interfered by this zone. This zone is also having lambda by 2 difference with this. So first ray and first ray lambda by 2, second ray lambda by 2, like that. So these get cancels. So what finally without getting disturbance are going? This one third portion. This 1/3 portion will go and give a bright fringe. So what is this 1/3 portion? Giving a small. Earlier I am having at central I am having all full portion. Here I am having 1/3. Similarly, instead of 3 by 2, if it is 5 by 2, so 4 sections get cancelled. So 1 by 5 will give me a bright fringe. This is 1 by 3, this is 1 by 5, 1 by 7, like that I will get bright fringes. So this is lambda by a, this is 2 lambda by a, this is plus 2 lambda by a, 3 lambda by a, like that. So in diffraction, see in interference I am getting equal intensity in all rays because I am having two sources. I am having two independent sources, they are interfering. I am having bright and dark both equally. But in diffraction, there is a one source which is diffracting, it's interfering with itself in different sections, and I am getting a central high maxima and some reducing intensities maxima as you go by lambda by a. Let us see. Path difference is x. Let us say this is the path difference x, which is a sine theta, which is again we have seen a into y by d. This is y, this is d. So d. So this is y. If y by d is the path difference, if path difference is lambda, that means totally I am getting destructive interference and I am getting a dark fringe. So y minima at what I am getting? Lambda into d by a on both sides. If d is 1 meter, d is 1 meter, then how much it is becoming? Lambda by a, that is what it is written. Lambda by a, lambda. In fact, it is multiplied by d, but d we have taken as 1 meter. So we can have removed the d length here. It is actually lambda d by a. Similarly, for nth minima, these are all minima. Minima means what? The path difference is n lambda. You see the difference. In interference, if the path difference is n lambda, I am getting a maxima. But in diffraction, if the path difference is n lambda, I am getting a minima, dark fringe. Similarly, in interference, if I am getting n plus 1 to n minus 1 by 2 lambda, to n minus 1 by 2 lambda d as a path difference, then I am getting a destructive interference. But here I am getting 1.5, 2.5, I am getting 1/3, 1 by 5th, I am getting constructive interference with reduced intensities. So that is the difference between diffraction and interference. So for nth minima, I am getting n lambda d by a. So this is for diffraction. Similarly, for a path difference of 1.5 lambda, I am getting 1/3 of rays will form the secondary maxima. For nth secondary maxima, x should be 2n plus 1 into lambda by 2. 2n 1 into lambda by 2, this should be the end. Then it becomes a y by d. So y becomes 2n plus 1 by 2 into lambda d by a. So width of central maxima is how much? Width of central maxima is minus lambda a by a plus lambda by a. It comes to 2 lambda by a. So 2 by a. Width is 2 lambda d by a. Of course, d is taken here. 2 lambda d by a. If in terms of theta, so in theta is d theta. The distance is d theta. So when by d, it will become by t. So in terms of d, in terms of theta, it is 2 lambda by a. So if you see here, for Fraunhofer, d is f. What is f? F is the focal length of this lens. You put a lens here, focal length, because I need focus at this point. The rays have to focus at this point. For Fresnel, we will get d as per v. Separate distance we get. So Fraunhofer are distance rays. Now we have seen in earlier that resolution. For a telescope, theta is the resolution. For a microscope, d 1 by d is the resolving power. For a telescope, d theta is the resolution power. So here we have observed 2 lambda by a. Lambda by a is for theta on both sides. So for a clear-cut message, Rayleigh's criteria says that if central maxima of one object falls onto first minima of other. Suppose there are two distant objects. If one object is falling here, if another object ray falls here, then I can see both clearly. Because this is this, for this it will be like this, second object. So I can see both objects. If it is going before this, I cannot see. There is a interference, there is a diffraction. I cannot see distinctly two objects. But if it is falling here, I can. So the gap between this should be lambda. So 1.22 for a spherical linear slit, it is lambda by a for a linear slit. But if it is a spherical slit, we have 1.22 lambda by a. So resolving power is 1 by theta. Similarly, for a microscope, d should be 1.22 lambda by 2 sine beta. Sine beta is the semi-angle at the sample and my lens, object lens. So resolving power is 1 by d. So what is this distance? 1.22 lambda. What is this 1.22 lambda by a? This is this diffraction, this distance. So one object is, I can see at this point, another object at this point. So it should be, the difference should be lambda by a. Here also I can see lambda by a. So from here to here, if the both objects are forming at this distance, at a lambda by a distance, I can distinguish. That is the resolving power. Okay. Now we have Fraunhofer and Fresnel diffraction, two different diffractions. This is for source at infinite, and the source nearby. And this is a plane wavefront. This is spherical or cylindrical wavefront. So the diffracted wavefront is also plane. The two convex lenses are required to study the Fraunhofer diffraction lenses. Two lenses are used. But here no lens is required. We can straight away study. These are easy and well-defined maximas and minimas are formed. These are not well-defined minimas are formed. Now let us see the polarization. Polarization means what? A light coming here, it is electromagnetic wave. It is all round, perpendicular to the propagation. We have electrical and magnetic waves in all plane, entire plane. So when they send through a crystal, what happens? In this direction only the electrical signals are there. All other three-dimensional or two-dimensional, this is a plane. Third dimension is going, plane is progressing forward. So two-dimensional plane, let us say pi r square. So all 0 to 360 degrees, the electrical and magnetic lines are moving. So when I cross this, I will get only vertical, a vertical dia with this alignment. So it is a single polarized. The light here is blur and light here is very clarity. Suppose we see sunglasses, window panes, 3D pictures, headlights, the LCD screen. If we get a blurred image, it cannot be clear. So that way more and more polarized light we are using, the screen, the TV screen is around more clear and clarity. So that is use of polarization. So these, what are these materials? Some calcine, quartz, tourmaline crystals. They reduce the glare. So there is a prism prepared of this Nicol prism. We call it as a Nicol prism. It is a calcite prism, and we have put a basalm here, Canada basalm it is called. Why Canada basalm? Because ordinary ray mu is 1.658. An extraordinary ray mu is 1.486. So I need a mu between these two, 1.6 and 1.5. So I have a mu 1.55, that is Canada basalm. So what happens when the unpolarized light is coming? It converts into two rays, extraordinary ray and ordinary ray. So ordinary ray is 1.658, the mu is more, so it is coming from a denser to a lighter medium, so it goes total internal reflection. But the other one, which is extraordinary ray, it won't follow Snell's law. It will go straight away. So I am getting a polarized light here. Is it polarized right here? Because this mu is less. Mu of extraordinary light is less. So I am differentiating from light to a ordinary light and extraordinary light. So it is. So dichorism is absorbing one ray and allowing the other ray. So it is almost reflected, allowing one ray. This is called Nicol prism. If you see the angles here, it is 72 acute angle. Here it is 108, and the ratio of length to breadth is 3. L is equal to 3 breadth. So these are the how it has been designed and made by Nicol. To you have a polarized light. Different ways of getting a polarized light. Brewster law. What Brewster said? Suppose an incident ray is converted into a reflected ray and a refracted ray, and if there is an angle between reflected and refracted is 90 degree, then it is observed that the reflected ray is plane polarized. So that means this is 90. So how the equation comes? Sin I by sin R is mu. Okay, sin I by what is R? R is nothing but 90 minus I. So R is nothing but 90 minus I, that is cos I. So tan I. So if I am giving a incidence tan inverse mu at this angle, I am getting a plane polarized light. This is what observed by Brewster. Total internal reflection is different. Sin C is 1 by mu. From denser medium to rarer medium, it is 1 by sin C. The outlet light goes grazing the surface. But the Brewster law is a reflection and refraction, both giving us a 90 degree angle between these two, rising to a polarized ray. Now here, law of Malus. Law of Malus. What law says? Suppose I intensity is there. It crossed one polarization. The intensity became I by 2. Intensity became I by 2. Suppose if it crosses, it is not fully polarizing. It is I am rotating it. This is second polaroid. I am rotating it. How the intensity outside is appears? So if it is 90 degree, I will get 0. So the intensity outside is given as I0 by 2 here into cos squared with theta. So if theta is 90, then it is 0. If theta is 45, then it becomes I by 4. So intensity is I by 4 at 45 degree. So this is the formula. Yes, when I am doing two polarizations, the intensity is either reduced or made. So I can control. See, all these things are used in our digital clocks. How digital clock is functioning? Only that polarization light will go, and you will get either 7 figure or 8 figure or 2 figure or 1 figure. Because of the polarization, you will get that light only will pass through that range, and you will get the value of the figure. All digital clock, this phone appears using this polarized light. Okay. Now you see some other way of polarization. Suppose in metals, electrons, they oscillate with the non-polarized light. Suppose light is falling on metals, the electrons are there in metals, they oscillate with electrical vectors and emits a plane polarized light. This light, when passes through metals, emit a plane polarized light. Similarly, in gases also they emit a plane polarized light, but in a 90-degree angle. Takes place perpendicular to the plane of the propagation. But in metals, it provides parallel to the plane of the propagation. But in metals, in gases, they also oscillate, but they oscillate perpendicularly to the light incidence, so they form perpendicular polarization. Okay, thank you.